Hi, I'm Carly McAvoy, and I'm doing the review for the final exam today. And I'm going to be doing this just on paper, so you can just double click on the screen with the paper in it so that you don't have to see my face. And I'm going to be doing chapters, each chapter separately, so a different video for each chapter. First chapter where I'm going to do is chapter 8 because that's the one I think might be the most important. This starts off asking you to solve quadratic equations, and we looked at more than one method for solving quadratic equations. If it's in this format where you have a perfect square over here, what you're going to do is you're going to take the square root of both sides. Remember that when you take the square root of something to the second power, those two things just cancel each other out. So you get 1 minus x minus 1/4. And the square root of 9, we're going to get plus or minus 3 because we need two solutions whenever we have something to the second power. So I'm going to solve that. X minus 1/4 is 1/3. X minus 1/4 is negative, I don't know, 1/3, geez, 3 and negative 3. I don't know where that came from. And so I'm just going to, you can use your calculator to do that arithmetic, but we're going to do add 1/4 to both sides. And so that's going to give us our two solutions. 3 plus 1/4 is 13/4. And negative 3 plus 1/4 is negative 11/4. And for those of you that don't do fractions very well in your head, you can do that on your calculator depending on what calculator you have. But here I'm just going to say 3 plus 1/4. That gives me 13/4, or negative 3 plus 1/4 gives me negative 11/4. So I can do that on the calculator. I can do it in my head. You will have a calculator with you. The second one is a complete the square type of problem, and that one we're going to take the negative 2 and shoot it to the other side, make that positive 2. And then I'm going to take b. Remember, when we have a quadratic equation, general form or standard form is ax squared plus bx plus c. So when I say b, I'm saying the coefficient of that middle term. I'm going to take b divided by 2 and square it. 8 divided by 2 is 4. This is the little formula. 8 divided by 2 is 4, squared is 16. Now notice that I added 16 over here, so I need to add 16 over there as well. And now I'm going to factor. This is going to be easy because whatever I had, it's always the square root of this number, so it's going to be x plus 4 squared, and over here is 18. Notice now I've completed the square, and so that equation matches what we did over here. And so I would finish that by taking the square root of both sides, and I would get x plus 4. And then over here, I'm going to get plus or minus. You can do the square root of 18 on your calculator. It's going to be 3 square root of 2. You can do it in your head, whatever. But if you take the second function, square root of 18, that's going to simplify to be 3 square root of 2. Because it's really, when you have 18, it's like having 9 times 2 under there, right? And the square root of 9 is 3, and then the square root of 2 we can't do. And then I'm going to subtract 4 from both sides, and that's going to give me negative 4 plus or minus 3 square root of 2. Could you have used your quadratic formula on that? Yes. But we would like to see that you can do different methods to solve these. That's 2 different methods, and now here's the third one. In this one, I'm going to use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac. You get to have 1 page of notes when you come into your final, so have that formula in there. Right now I can see that a is 4, b is 10. What about c? Oh, well, that's a problem. I shouldn't have written right under that because I really need to move that 3 to the other side before I can see what the c is. So I don't say c is -3, first you move it to the other side and then you can see. So now I have, then you can see c. So I have negative b, that's -10, plus or minus the square root of b squared, which is 100, minus 4 times a times c. Well, 4 times 4 is 16, times 3 is 48. So I've got minus 48 all over 2 times a, which is 8. Now I'm going to simplify. I keep grabbing the mouse instead of the calculator. Let's see. I'm going to simplify this second function square root of 100 minus 48 is 2 square root of 13. My calculator does that nicely. I'm always pushing the 36x Pro because it's so great to do that, but if you can do that on your own without using the calculator, which is fine, I get 2 square root of 13, that was 13, over 8, and then notice that 2 goes into all 3 of these. So my final answer is going to be dividing all these by 2, -5 plus or minus the square root of 13 over 4. And that's going to be my final answer. It's actually x equals. And then up here, if you didn't know how to, if you couldn't use your calculator to simplify that, that square root of 52, we talked about that, or in previous videos, you could find the prime factorization. And what you'd find is that is 2 to the second power times 13. And that's how that 2 ends up coming out front and the 13 is left in there. But if you can use your calculator effectively, man, you can save yourself a lot of time. Okay, the next one is looking at a problem where you have to figure out the max height of something, and that's a vertex problem. And so to find the vertex of something, this one says the path of a shot put is modeled by this equation. What's the max height? It says that x equals the horizontal distance. What does that look like? Well, somebody's here and they throw a shot put and it goes up for a little while and then it comes down. So when we're talking about the max height, we're talking about the vertex of that flight path. So that's what we're looking for there. And then it eventually comes back to the ground. We're not going to talk about what if it rolls around. The distance they get is when it hits the ground. And it asks for the horizontal distance at the max height. So we want to know this, which we want to know the maximum height and the horizontal distance. The horizontal distance is down here, right? This is horizontal. And this is the height coming up this way. Okay, and so if I look at this formula, what I know for sure is that this person let go of that shot put at 6.1. That's the 6.1 feet is how high it was when they released it. Okay, that's the y-intercept. Okay, so I know that, and I know that to find the vertex, my x-coordinate is -b over 2a, and the y-coordinate is you plug in the x as you find it. So that's what I need to do. So I need to take 2.1 and divide by 2 times negative, it's negative b, so negative 2.1, 2 times negative 0.04. That's negative b over 2a. And of course, you're going to use your calculator for that. Negative 2.1 divided by 2 times negative 0.04. Make sure when you enter negative, you're not using your subtraction symbol, but you're actually using the negative symbol down below. And that gives me 26.25. Is that the x or the y? Well, that's the x, and they told us in this problem x was the horizontal distance. So what I know is when that thing reaches its vertex, it's gone 26.25 feet. And then, even though it asked for the max height, that's not the first thing I found. To find the maximum height, I'm going to take my function and I'm going to plug in the answer I just got. I did not write very smartly. I'm barely squeezing this in. That's what I'm plugging in. And of course, I'm going to do that on my calculator, negative 0.04 times 26.25 squared plus 2.1 times 26.25 plus 6.1. And what I get is 33.66, depending on where they ask you to round it, but I'm going out to 2 places. So that means it was the maximum. That seems really high. This is wrong. What the heck did I do here? I didn't really think about the answer until I got that. And nobody's flinging a thing 3 stories high. 2 times negative 0.04. Yes, I did get that. Negative 0.04. Well, the 2 negatives make a positive. That makes sense. I took this out of the textbook. And maybe I copied it down wrong. But is somebody really throwing a shot put 33 feet into the air? I don't think so. Crazy. The process is correct. I'm not going to go back and deal with that. But I don't. Sometimes they do make questions that don't really make sense to me. The fact that it goes 26 feet across to get to the horizontal does make sense. And but the other part doesn't. Let me try it one time on my calculator just to make sure that I didn't punch something in wrong. Times negative 0.04 plus 2.1 times plus 6.1. That's what I got again. So I got it twice. I just don't like it, but whatever. And then the other question is, what's the max distance? That is, how far does it go when it lands? Well, what is the height when it lands? Well, the height when it lands is 0, and that's what this is. So what I'm going to do is say 0 equals negative 0.04x squared plus 2.1x plus 6.1. And then you can use the quadratic formula like you did up here to solve that. You can also use your calculator. Did you buy a TI 36X Pro when I was pushing it? Because what a great little thing this is. You would go second function polysolve. And we want to choose the first one, which is a quadratic equation. And then it says, well, what's your A, which is negative 0.04. And then what's your B? Well, our B was 2.1. And then what's your C? 6.1. And then we solve it. The first answer is negative 2.7596. Well, we can't have a negative, so that doesn't make any sense. We don't have negative distances. So then you hit enter, and the second one is 55.26. I'm going to pause you here for a second. Okay, sorry. All right, so that's the height. The max distance, I mean, is 55.26. And so if you don't have a calculator that can do that, then you're going to have to plug in negative 2.1 plus or minus the square root of 2.1 squared minus 4 times A times C all over 2 times A and solve that. And so the other thing you might, well, no, I won't go into that. But anyway, so solve that and see if you can get the right answer that way. All right, moving on from chapter 8, for chapter 8. There's quite a bit in chapter 8, so I want to keep going. I want to talk for a minute about just understanding what you're seeing when you're looking at a quadratic equation. And so this question, there's one question on the final that's just asking you to not do any calculations, but just sort of interpret. So the standard form of a quadratic equation is y equals ax squared plus bx plus c. C is your y-intercept. A determines whether your quadratic equation opens up or down, your parabola. If A is greater than 0, it opens up. If A is less than 0, it opens down. In other words, positive is up, negative is down. And when you solve an equation, if you were to solve this equation, you're finding the x-intercepts. That's where it crosses the x-axis. So for each of the following, give the sign of A and C and the number of real solutions. Well, this is opening down, so I know for sure that A is less than 0. Okay. This one also is crossing the y-axis in above 0, so I know that C has to be positive. I can just see from the picture. C is the y-intercept. Where does it cross the y-axis? Above 0, that's positive. How many real solutions? The solutions are x-intercepts, so there's 2 solutions. For this one, the equation is opening up. If it's opening up, then I know that A has to be greater than 0. Where's the y-intercept, or C? C is right here. Again, C is positive because I can see it's crossing above that. How many solutions do you have? It touches the x-axis 1 time, so you have 1 solution. And the third one, well, the third one's opening down, so I know that A must be less than 0. It has a y-intercept down here, and that's below 0, so I know that C is also less than 0. And it doesn't touch the x-axis ever. So there's 0. And when I say solutions, what I'm actually talking about are real solutions. There's imaginary solutions for this one, but that's not what we're talking about. Okay, so that's A, C, and number of solutions. And the next thing asks you to find the intercepts, the vertex, and graph of this equation. So to find the vertex, remember I'm going to do negative b over 2a and then plug in the x. So I'm going to start with that. I'm going to take negative 4 over 2 times 1. That's my 2a. That's going to give me 4 divided by 2, or 2. This is my vertex. How do I find the rest of that? I plug it in. So f of 2 is actually 2 squared minus 4 times 2 minus 5. And that is 4 minus 8 minus 5. Negative 4 minus 5 is negative 9. And so my vertex is at 2, negative 9. And that's part of what they want. The intercepts, well, to find the y-intercept, it's right here. So the y-intercept is negative 5, which is 0, negative 5. Here's my vertex. Here's my y-intercept. My x-intercepts, well, my x-intercepts, I set this equal to 0. And C, because I'm solving, to find the x-intercepts, I'm saying where is my equation equal to 0. Sorry, I smeared that with my hand. So I'm going to factor that, x minus 5 and x plus 1. And once I get those 2 solutions, I now have my x-intercepts. And then I'm going to graph that equation. So very kind of sloppy graph here, but it's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my vertex is at 2, 9. My x-intercept is at 5. My other intercept is at negative 1. I found my y-intercept 1, 2, 3, 4 to be negative 5. I can use those points to graph the equation. And you'll find that if you do it on Math Excel, you actually put in the vertex and one of the intercepts, and it'll graph the rest of it for you nicely. Okay, the last thing about Chapter 8 that I want to talk to you about is vertex form of an equation. You'll see this a lot if you take pre-calculus. You'll never see it again if you're going somewhere else. So the vertex form is different. It has the x and the y. This could be y instead of x, but you have a in the front. Again, a tells you whether it opens up or down. This tells you the horizontal shift, and this tells you the vertical shift. I don't know why I wrote 5 there, because it's k in general form. I don't know. I think I might have been looking at an example and did that. Okay, that should be k. So anyway, what I know then is hk is the vertex. So if I have y equals -3, x minus 3 plus 2, then the vertex is 3, 2. Now if I have y, and also this is negative, so it would be something opening down with the vertex at 3, 2. If I have something like 2x plus 2 minus 1, well then that plus is there, and it's supposed to be a minus in the formula. That means my h is actually -2. So for this, my vertex would be -2, -1. It's always exactly what you see at the end for your y part, and then because this is +2, it's going to open up. And one last one, if I have f of x equals -x plus 5 squared, that should be squared, and that should be squared, sorry, plus 7, my vertex would be -5, 7, and this parabola would be opening down. Okay, that's the video for Chapter 8. I'll get on the other ones as soon as I can.